My name is Forreryd. I have a Master in Science in Biotechnology. I have a PhD in Immunotechnology, and now I work for a company that is called Senzagen, and we develop in vitro assays for skin and respiratory sensitization. So at Senzagen we develop in vitro assays for different type of toxicological endpoints. So for the moment we are focusing on developing in vitro assays for skin sensitization and for respiratory sensitization, but we are a really research-oriented company, so we continue to work and expand our portfolio of different in vitro assays. The whole initiative with the Senzagen company is basically to develop in vitro assays. So our ambition is to develop in vitro assays that are so good that they can replace all the animal models. So we do not perform any type of animal models, and the reason is basically because, I mean, it has been shown in several studies now as well that animal models are not very predictive of the human toxicity. And that's why we believe that we can actually improve the predictive performance by using in vitro assays instead of animal models. So sensitization is basically an allergic hypersensitivity reaction. So if we talk about, there's different type of sensibilization. So you can, for example, have an adverse immune reaction in the skin. So that means that a specific chemical that should not actually be toxic to you, it will actually interact with your immune system and cause an adverse effect. So it's basically chemicals that affect different signaling pathways and activates the immune system, and then cause some skin rash or any other problems in the skin. You can also have other type of reactions, such as respiratory sensitization, and then the chemicals can induce, for example, respiratory symptoms such as asthma instead. So the GARD stands for Genomic Allergen Rapid Detection. So the assay was basically developed first for identification of chemicals that are capable of inducing skin sensitization reactions. So it's basically a screening tool for cosmetic industry, for the agrochemical industry, or for the pharmaceutical industry to test their chemicals and make sure that they do not induce any adverse reaction in the human in terms of skin sensitization. So it's basically an in vitro platform. So we use a human relevant cell line that we expose to the test substance. And after that we measure genomics. We measure basically how the genes react to this substance. And then we use machine learning in order to classify the substance as either a sensitizer or a non-sensitizer. So for skin sensitization this has turned out to be very predictive. So I think we have an accuracy of slightly above 90%, which is way better than the animal model. So now we have also extended this concept to test for respiratory sensitizing chemicals, and this is something that we work really hard on now.